Okay, so I wanted to do an example like he did. So come up with a multiplication, and then we're going to do it the 4 different ways that he did, and we're going to see that those all produce the same number.
Alright, so say we
You can
have...
erase the family math if you want to give yourself a little bit more room.
Maybe we have the number 14, and then we're multiplying that by 25, right? I think that's kind of a round number, so maybe 29. Well, so we start doing it the normal way we had before. We draw out a rectangle, so we have 14 and 29, and then we split it up into 20 and 9. And then we split this up into 10 and 4.
Okay.
So we get 200, we get 90, we get 80, and we get 36. 200, 290, 370, so we get 14 times 29 is, not 446. 290.
290.
Say it's 370.
370.
Plus 36 is 406.
Okay, yeah, I see it. Great. All right, so that was the first way.
So then he wanted to start kind of doing it a little bit differently. So maybe we do the rectangle.
Don't worry, you don't have to put them all on the
Yeah.
page together, so use as much room as you need.
Then he changed the first number to make it 20 minus 6.
Okay.
And then we're going to be multiplying that by 29. So we still have the 20 and the 9. But we have, and this over here, we have 20 and minus 6. So we get 400, 180, 120, and this is negative, and then we have negative 54. So we get 400, we go up to 580, we go back down to 460, subtracting 54, we get 406 again.
Okay, is that good that we got the same number?
Yeah, we want to get the same number because 20 minus 6 is the same as 14.
Yeah.
So,
Alright, cool. You're going to try to squeeze them all on?
yeah.
Maybe you can maybe erase the 406s and actually just write it up there so we remember. That might give you enough extra room. If you want to squeeze them all on, that's fine.
So, the next problem is we have 14 and then we're going to change this to 30 minus 1. Actually, I'm up here a little. 30 minus 1 is the same as 29. So we have 30 and the minus 1. So a little section there. And then we have the 10 and the 4 was the same as the first problem. 300, negative 10, 120, and negative 4. And here we get, let's see, 290, and so we get 410, and then minus 4 is 406.
Nice.
Keep going.
Okay.
And then for the last one, we want to do it with both the numbers that are changed. So we have 20 minus 6 times 30 minus 1. And the thing that we don't know here is what a negative times a negative is. We said in the video, we don't really know what that is, but so by figuring this out, so we have 30, negative 1, and we have 20 and minus 6. 600, negative 20, negative 180, and we don't know.
Okay.
So, then we know the answer is 406. So, see, we get 600 and then minus 200, so we get 400.
Mm-hmm.
400, and you have to add whatever -1 times -6 is to get 406. So now you can see that -1 times -6 is positive 6. So that means a negative times a negative must be a positive.
Cool.
And that's how we figured that out.
Nice. So what do you think about this as a way to see that negative times a negative is a positive?
I think it's a really neat way of doing it.
Yeah, I do too. I do too. Yeah, this is cool. Are you surprised about anything about this method overall?
Well, the thing is, maybe using like negative numbers as side lengths. I guess maybe you start with 30 and then you subtract away. I think you can sort of see that, but I've never done it before.
Okay. Do you think there's such a thing as negative area?
No, I don't.
You don't? But
I mean, maybe if you're subtracting stuff away, but there's no, like, you can't have negative space.
you can't have negative space.
I mean, but the total area here was positive, because you weren't taking all of it away.
Okay. That's right. I think we're okay.
Yeah.
Cool. Yeah, this is a really neat method and a cool way of thinking about this. Let me just ask you one other question that just popped into my head right this second. How do you think you would multiply 3 numbers like this?
Maybe using a cube. If you had like, maybe if a 4-dimensional person had something like this, then they could do it using a cube.
Cool. All right. Hey, good work this morning.